Hello learners. So after learning about what are the numbers and how to find the factors of a number, let us now look at the hierarchy of arithmetic operations followed by the rules of divisibility. So let us quickly jump into the concepts and solve some questions. So in the case of hierarchy of arithmetic operations, we will be considering 6 operations. And the rule is called as BODMAS, BODMAS, wherein B stands for brackets. There are 4 types of brackets basically: vinculum, simple brackets, curly brackets, and square brackets. So vinculum is nothing but, let us say, this is the number 2 minus 3 plus 5, and there is a bar over 3 plus 5. So this means that the bar is a vinculum and the addition will be done at first. So it will be equal to 2 minus 8, which is equal to minus 6. And simple brackets, curly brackets, and square brackets operate in the similar fashion. And a generic notation for the usage of these other 3 brackets is square bracket, inside it curly, and inside it simple bracket. So 2 plus 5 minus 3 plus 4. So this is a example of brackets. And the answer for it will be 2 plus 5, 7, 7 minus 3, 4, and 4 plus 4, 8. So 8 will be the answer. And in the case of brackets, we move from inside to outside. So that is pretty much about the brackets. And now let us look at the next type, rather the next arithmetic operation, which is of, which means, for example, half of 6 or twice of 9. So half of 6 is equal to 1 by 2 into 6, which is 3. And twice 9 is equal to 2 into 9, which is 18. Okay. So after the brackets, we will solve of. Then there are some other arithmetic operations as well, which are division, multiplication, addition, and subtraction. So we have to follow this order strictly. So let us see an example. So the example is, let us say, 2 plus 5 in brackets divided by 3 minus 4 plus 6 into half of 12. Okay. So for solving it, we will initially solve the bracket, which is 7. Then there is a 3. So 7 by 3, we will keep it as it is. Minus 4 plus 6 into half of 12. So half of 12 is 6. So 7 by 3 will be as it is, minus 4 plus 36. And here we will move from left to right. So 36 minus 4 is 32, and 32 3s are 96. So 96 plus 7 is 103 divided by 3. So this will be the answer of it. So now let us move at the rules of divisibility. So before that, let us understand 3 basic terms, which are multiples, co-primes, and twin primes. So see, multiples mean that it is reverse analogy of factors, nothing else. For example, 2 is a factor of 6. So 6 is a multiple of 2. Okay. Now, co-primes. Two numbers that do not have any common factor other than 1 are called co-prime numbers. For example, any pair of prime numbers will be co-prime for sure. For example, 2, 3, 5, 7, 11, 67, and so on. But two pair of composite numbers can also be co-primes. For example, 4, 9. So these two are co-primes. The numbers individually are not primes, but relative to each other, they are co-prime numbers. So this is about co-primes. And the last thing is twin prime numbers, which are a pair of numbers that differ by 2. For example, 5, 7, 11, 13, and 3, 5. So these are twin prime numbers. Okay. Now we will be looking at the rules of divisibility. So the first one is divisibility by 2. So a number is said to be divisible by 2 if the units digit is even. For example, 1, 2, 7, 5, 8. This is divisible by 2. 1, 3, 4, 5, 9. This is not divisible by 2. Okay. Then comes divisibility by 3, wherein sum of all the digits should be a multiple of 3. So a multiple of 3, as seen earlier, is 3, 6, 9, 12, and so on. Okay. So 243. What is the sum of digits? 2 plus 4, 6, 6 plus 3, 9. So this is divisible by 3. And if we had taken a number 649, let us say, so 4 plus 9, 13, 13 plus 6, 19. This is not divisible by 3. So this is about divisibility by 3. Now let us look at divisibility by 2 to the power k. So we have already looked at divisibility by 2. And in the case of divisibility by 2 to the power k, wherein k belongs to the set of natural numbers. So last k digit should be divisible by 2. For example, let us say we have a number 1756 and we have to check the divisibility by 8. So what we will do is take the last 3 digits and check whether it is divisible by 8 or not. So 8 is equal to 2 to the power 3 and 756 divided by 8. So 8 nines are 72 and 36. So 8 fours are 32 and it is 94.5. So it is not divisible by 8. Okay. If the number had been 1760, it would have been divisible by 3. Because 1760 divided by 8 is equal to 95. Okay. So this should be pretty simple to understand. Now let us look at some different set of numbers for which we can see the divisibility. Divisibility by 5. This is again a simple one because all we have to do is we have to check the units digit of a number or say the last digit. So units digit should be either 5 or 0. So 1, 2, 3, 4, 7, 9, 6, 8, 5. This is divisible by 5. And if there was a 4 in the units digit, it would not have been divisible by 5. Now, divisibility by 6. So for a number to be divisible by 6, it has to be divisible by 2 as well as 3. For example, 7, 3, 2, 4. 2. Let us say this is a 5-digit number and we have to check its divisibility by 6. Now for 6, it should be divisible by 2. So for divisibility by 2, the units digit should be even. It is even. And for divisibility by 3, the units, sum of digits rather, should be 7 plus 3, 10. 10 plus 2, 12. 12 plus 4, 16. 16 plus 2, 18. It is also a multiple of 3. So it is divisible by 3 as well. So divisibility by 6 is valid. And in general, if you have to check the divisibility by composite numbers, then what you do is break it in the form of its prime factors, and it should be divisible by all its prime components, not just prime factors, prime components. So if a number is equal to 12 and the given number is, let us say, 73248. Let us say this is the number and we have to check the divisibility by 12. So 12 is equal to 2 square into 3. Now divisibility by 2 square can be checked by checking the last two digits, 48. 48 is divisible by 4. So it is valid. And divisibility by 3. So 7 plus 3, 10. 10 plus 2, 12. 12 plus 12, 24. So it is divisible by 2 square as well as 3. So it is divisible by 12. So that is pretty much it for the divisibility by composite numbers. And then we will check the divisibility by some more numbers. The first one being 7. So divisibility by 7 means that the number should be of the form 7k, wherein k is a natural number. So for checking the divisibility, what we simply do is, let us say we have an example 4, 5, 6, 7, 4, 5. So here we take the units digit apart and the remaining part apart. So 4, 5, 6, 7, 4 minus 10. So this is 4, 5, 6, 6, 4. Now 4, 5, 6, 6, 4. The units digit is 4. So we take it apart and this is as it is. So 4, 5, 6, 6 minus 2 into units digit, which is 8. So this is equal to 4, 5, 7, sorry, 5, 8. Now units digit is again 8. So 4, 5, 5 minus 16, which is equal to 15 minus 6, 9, and 44 minus 1, 43, 439. And for this number, we will do 43 minus 18, which is equal to 13 minus 8, 5, and 3 minus 1, 2. This number is 25. Now, we have to check whether this number is divisible by 7 or not. So, we will do this iteration until we reach to a smaller number, which is easy enough to recognize whether it is divisible by 7 or not. Now 25 is not divisible by 7. So 4, 5, 6, 7, 4, 5 is also not divisible by 7. So this is how you can check for divisibility by 7. So let us take another example. 1, 2, 3, 4. Okay. So let us take an example. 1, 4, 2, 8. 0.57. Or rather, let us say the number is 142856. Okay. So for this, what we will do is we will take the units digit, multiply it by 12, and subtract it from 14285. So this is equal to 5 minus 2, 3, 7, 142. Take the units digit, multiply it by 2, and subtract the remaining portion from it. This is equal to 1421. Take the units digit, multiply by 2, 2142 minus 2. It is 140. Now see, 140 is divisible by 7. We can recognize it. So this is also divisible by 7. So this is how you check the divisibility by 7, wherein you take the units digit, double it, and subtract it from the remaining part. And do this iteration until you reach a recognizable number to comment on whether it is divisible by 7 or not. So now we will look at the divisibility by 11. So for checking the divisibility by 11, what we will simply do is we will add the alternate terms. So for example, the alternate terms are 2 and 2. So 2 plus 2 is 4 and 3, 1, 1. It is 5. 5 minus 4 is 1. Now we need to check whether a number that is acquired by the difference of sum of alternate numbers, alternate digits rather, in the given number. So whether it is of the form 0 or 11k, wherein k belongs to set of whole numbers. Okay. So we have to check whether it is of the form 11k or not. Now here it is not of the form 11k. So this is not divisible by 11. So let us check it for 14641. Now the alternate digits will be 161, which is 8, 4 and 4. It is 8. 8 minus 8, 0. It is valid. So it is divisible by 11. Now let us check the last rule of divisibility. So it is divisibility by 19. It is pretty similar to divisibility by 7, but instead of doing 4, 5, 6, 7, 4, 5, let us take the old example only. Now we double the units digit and add it. Rather than subtracting, we add it. So 4, 5, 6, 7, 4 is plus 10. This is 4, 5, 6, 8, 4. We take the units digit, multiply it by 2, 4, 5, 6, 8 plus 8. This is 8 plus 8, 16. So 4, 5, 7, 6. We take the units digit, multiply by 2 and add it to the rest. So 4, 5, 7 plus 12. This is 9, 4, 6, 469. Now we do the iteration once again. So 46 plus 18. It is equal to 6 plus 8, 4. 4 plus 1, 6, 64. Now 64 is not divisible by 19. So let us now see the last two rules of divisibility, which are divisibility by 9. Okay. So for divisibility by 9, there is a simple equation. The sum of the digits should be equal to 9 or a multiple of 9. For example, let us take a number 729,342. Okay. Now what is the sum of the digits? 7 plus 2, 9, 9 plus 9, 18. 18 plus 9 is 27. So this number is divisible by 9. Okay. So this is for the divisibility by 9. And the last one is divisibility by 5 to the power k. Okay. So sum of digits should be a multiple of 3 to the power 2 here. There is a typo done. So yep. And lastly, the divisibility by 5 to the power k. So in the case of divisibility by 5 to the power k, last k digit should be a multiple of 5 to the power k. For example, 129,625. And we have to check its divisibility by 5 to the power 3, which is equal to 125. Now, for this, we will take the last 3 digits because the exponent is 3, and we will check whether it's divisible by 125 or not. So 125 into 5 is 625, so it is perfectly divisible. So the formula, if you see, for 2 to the power k and 5 to the power k is almost similar to each other, right? Wherein we take the last k digits and check whether it is divisible by that particular number or not. So that is pretty much it from this particular video. And in the next video, we will be looking at what are HCF and LCM. So stay tuned and happy learning.